is variance? In probability theory and statistics, variance is the expectation of the squared deviation of a random variable from its population mean or sample mean. Variance is a measure of dispersion, meaning it is a measure of how far a set of numbers is spread out from their average value. The variance formula includes the sigma notation, which represents the sum of all the items to the right of sigma. The variance is the average of the squared differences from the mean. To figure out the variance, first, calculate the difference between each point and the mean. Then, square and average the results.
For example, if a group of numbers ranges from 1 to 10, it will have a mean of 5.5. If you square the differences between each number and the mean, and then find their sum, the result is 82.5. To figure out the variance, divide the sum 82.5 by n minus 1, which is the sample size, minus 1, the result is a variance of 82.5 over 9 is equals to 9.17.
Variance is an important tool in the science where statistical analysis of data is common. Variance has a central role in statistics where some ideas that use it include descriptive statistics, statistical inference, hypothesis testing, goodness of fit, and Monte Carlo sampling. Here are the rules for the variance. First, the variance of a constant is 0. Second, adding a constant value C to a random variable does not change that variance because the expectation mean increases by the same amount. Third, multiplying a random variable by a constant increases the variance by the square of the constant. Fourth, the variance of the sum of two or more random variables is equal to the sum of each of their variances only when the random variables are independent.
Good day, everyone. Today I will discuss the standard deviation. Please watch and learn. Standard deviation. The standard deviation, the range of a set of data, is easy to compute, but it can be deceiving. The range is a measure that depends only on the two most extreme values, and as such it is very sensitive. A measure of dispersion that is less sensitive. The most statistical application involve a sample rather than a population, which is the complete set of data values. Sample standard deviation are designated by lowercase letter x. In those cases in which we do work with the population, we designated the standard deviation of the population by sigma, which is a lowercase Greek. We can use the following procedure to calculate the standard deviation of n numbers. And this is a formula of population standard deviation and the sample standard deviation. This is the step to calculate the standard deviation for a population. Step 1. Calculate the mean of the data set. Step 2. Subtract the mean from each value in the data set. Step 3. Square the differences found in Step 2. Step 4. Add up the square differences found in Step 3. Step 5. Divide the total from Step 4 by n for population data. Take note, at this point you have the variance of the data. And Step 6. Take the square root of the result from Step 5 to get the standard deviation. This is my example of standard deviation of the population. Sample of the set number is 3, 5, and 7. 3 plus 5, 8, plus 7 is 15. And 15 divided by 3 equals 5. 5 is the mean. And then 3 minus 5 squared plus 5 minus 5 squared plus 7 minus 5 squared divided by 3. 3 minus 5 squared 4. 5 minus 5 squared 0. 7 minus 5 squared 4. Divided by 3. And 4 plus 4, 8 divided by 3, the answer is 1.63. And next, this is the step of the standard deviation for a sample. Step 1. Calculate the mean of the data set. Step 2. Subtract the mean from each value in the data set. Step 3. Square the differences found in Step 2. In Step 4, add up the square differences found in Step 3. Step 5. Divide the total from Step 4 by n-1 for sample data. Step 6. Take note at this point you have the variance of the data. In Step 7, take the square root of the result from Step 5 to get the standard deviation. This is my example of standard deviation of the sample. The set numbers is 82 plus 93 plus 98 plus 89 plus 88 equals 450 divided by 5 equals 90. Sample equals square root. 82 minus 90 squared plus 93 minus 90 squared plus 98 minus 90 squared plus 89 minus 90 squared plus 88 minus 90 squared divided by 5 minus 1. Sample equals square root. 82 minus 90 squared equals negative 8 squared. 93 minus 90 squared equals 3 squared. 98 minus 90 squared equals 8 squared. 89 minus 90 squared equals negative 1 squared. 88 minus 90 squared equals negative 2 squared divided by 4 is the answer is 5.958.
That's all for today. My name is Angelica Estoya, members of the Tribe 3 Helix. Thank you for listening.
Today, I will discuss standard deviation. Standard deviation is the set of data named standard deviation. Standard deviation is a measure of spread. Standard deviation is commonly used to understand for a specific data point. Standard, expectation, or unusual, or unexpected.
Standard deviation of the sample. Step 1. The mean of the number is minus 8 is equals negative 6, 4 minus 8 is equal negative 4, 7 minus 8 is equal negative 12 minus 8 is equal negative 4, 15 minus 8 is equal negative 7. Calculate the square of each deviation in step 2 and find the sum of this square deviation. Times 1 is equal 1. 4 times 4 is equal 16. 7 times 7 is equal 49. The sum of the square is equal 118. For step 4, because we have the sample of n minus 5 values, divide the sum of 180 by n minus 1, which is 4. 180 divided by 4 is equal 29.5. Step 5. The standard deviation of the sample is x is equal to the square root of 29.9. The standard deviation is equal to 3.4.
Hello everyone, I discuss the measure of dispersion range. The range measures the distance between the largest and the smallest values, and such as gives an idea of the spread of the data set. The formula of range is how to find the value of the range, that is, get the highest value and subtract and get the lowest value. Example, the given data set is 1, 5, 9, 10, and 22. By the following, the formula of range, highest value minus lowest value. The number of highest value is 22. Subtract to the lowest value of y is equal to 21. Therefore, our range is 21. Second example, 2, 3, 5, and 6, and 11. The 11 is the highest value. Subtract to the lowest value is 2 is equal to 9. Therefore, the range is 9.